Alright, so in the last video, last time you saw us, we were looking at these three really similar integrals. So how's the first one go, guys?
4 times 9 x over 3.
Pull some stuff out of it, right? Pull 4 and pull 9 out on the bottom. Because this is looking very much, we can't do a u sub because if you make u the bottom, I mean the whole bottom, there's no x lurking on top. If you make it just x, then that's trivial and you get a u integral that's the same thing. You should recognize that that kind of looks like what?
Arctangent.
Arctangent, exactly. So that's why Kylie's saying 9/4 is what needs to come out. So you could take it one step at a time if you like, and go like this. Or you could just pull 4/9 out from the very beginning. We need this to be a 1, right? That's why the 9 is coming out. So now this is going to be dx, and then this is going to be what? X over 3 squared, because when we pull 9 out of 1, we get 1/9, and that's how you make 1/9. Okay, so u substitution time. So 3 du is dx, so I'm going to stick 3 du there, so I get 4/9 integral of 3 du over u squared plus 1. You can pull that 3 out in front, so you get 4/3, because 3 over 9 is going to cancel, right? So you're going to get 4/3 arctangent of x over 3 plus c. There's the first one. Second one is almost identical. It's just got an x here. Does that mean it has a similar answer?
No.
Not even close. The answer's not even the same at all. This one's probably the easiest of the three, though, don't you guys think?
Yeah.
Because it's just ready to do a u sub right away, right? If I make u x squared plus 9, du then is 2x dx. And I've pretty much got 2x dx if I just divide, or however you want to think about that, right? So that's going to be equal to 4 integral, I guess I could divide this over here. So du over 2 over u. So this is, take that out and you get 2 integrals of du over u, which is equal to 2 natural logs of u, which is 2 natural log of x squared plus 9 plus c. Why did I get to drop my absolute value bars there? Because anything that you put inside of here as x is going to be squared, and then more positive stuff's going to be added on. So taking the absolute value at the end of that is kind of like, why? Right? Okay. Last one was one I wanted to see if you guys remember. Any ideas? Did you guys make any progress with it? I think you could do it a few different ways. There's more than one way to do it. You could do a u substitution with a key. So let me erase it. Notice though, the only difference is that's squared, right? So let's see if we make any progress with a u substitution with a key. So that's the natural u substitution, right? So du is 2x dx, but we have x squared, so that's an issue. You can solve for that x squared. You can come over and say x squared is u minus 9, so then you'd have u, bring my 4 out in front, so then this is u minus 9, and dx is what? If you go like this, you could say dx is du over 2x, so that'd be du over 2x. I know at that point that I'm not making as much progress as I'd like, but some problems you have to do this way. This is definitely not something you want to forget. The only problem is what so far? You have an x in there. Can we maybe get rid of that x somehow? We can try by solving for x. Let's try. Like up here you could go solve for x. I'm getting too much green. Hard to look at. So u minus 9 square rooted is x, right? So then we'd have root u minus 9 down there. So this is looking pretty simple, but like now you've got like 4 integral of, oh, let's bring that 2 out in front, right? So 2 u minus 9 over u root u minus 9. Yeah, but like arcsecant, you have to like split it into 2 pieces. I think you can do this problem this way. It's going to turn into a 2-piecer, and it's just going to continue to get more and more ugly. Can you do it this way? I think so. It's just going to get really explosive. We're going to have to like cover the whole board to do it this way. So at this point, I'm like, try something else. That's how integration goes sometimes. What's going to work? So this is really important in chapter 8. We're going to do a whole section where you got to remember this. Didn't do it too many times last year, but we're going to do it a bunch this year. If you have polynomials stacked on top of each other and their degrees are the same on the top or bottom, or in fact, if it's bigger on top, you should be thinking about dividing those. Yeah. So this is, if it was x cubed on top, x squared on the bottom, I'd definitely divide it. But even when they're equal like this, I'd totally divide it. So, not integrating, going back to 5th grade, I'm going to divide here. You guys, what am I dividing? And what am I dividing by? Dividing by x squared plus 9, right? I'm dividing 4x squared. So long division, let's recall, quite useful in this class especially. X squared times what will give me that? Quattro. Distribute it back.
No hablo español.
Always writing my minus for long division so I don't make mistakes like silly algebra students all over the world. 4x squared minus 4x squared, of course, goes away. I'm not going to write that 0. But what do I have here? Negative 36. How does this help us with this problem? Well, it's because it lets us rewrite this integration problem as what happens when you divide. You get the quotient plus the remainder. Well, this time it's minus, isn't it? Minus 36. The only part you've got to remember is, how do you write remainders the right way? If this was like 62 divided by 6, the answer would be 10 plus 2/6. So here it's 4 minus 36, x squared plus 9s. It's funny, but that's the way you should be thinking about it, yeah? Okay, so something we couldn't integrate into something we can integrate. Of course, the first one's easy, right? That's just 4x, and isn't this another arctangent? Yep. I think it is. So, don't forget about long division. So we're going to have minus 36 integral of, oh, should we just do what Kylie did last time? We just did this one a second ago. So I'll factor out the 9 on the bottom, and we'll have x over 3 squared plus 1 right there. If you need to draw another step in there, then do it. Are we okay?
Okay.
You guys seemed okay with it a second ago, so doing it again. Okay, so that's going to be 4x minus 4, and we can do that integral with a u sub, right? So you can write it over here, but it's basically going to be 4 arctangent of x over 3 plus c, correct?
Wouldn't you have a chain rule?
Good, 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 good.
So you don't
The u is x over 3, so to compensate dividing by 3, you have to multiply by 3. Wonderful, you guys are really good. You're feeling like a Calc 2 class, that's what I like to see. Notice, if you compare those 3 answers to those 3 integrals, they are like totally different. So there's all kinds of integration techniques. We'll see you next time when we start integrating by parts.